So we're talking about from 1 to 3 of the absolute value of x. Now, before I actually anti-differentiate it, I want to consider what that looks like graphically. So what does the graph of the absolute value of x look like graphically? It's a V, right? Where is its origin? I mean, where's its vertex? It's at the origin, yes. All right, I'll say something right here before the year's over. All right, so this is what I'm looking at here. Are y'all good with that? Okay, now, after that, what's my A value? 1. What's my B value? 3. Okay, so I'm going from 1 to 3. So this would be, thinking about area, that would be the area that I would be concerned with. Okay? Now, if I look at this, this does not really have anything to do, this part right here doesn't have anything to do with over here. And this is where I'm interested in. So what can I do? What can I consider this as, possibly? Do y'all see that? If I only look at this portion of, if I only look at this portion of the graph right here, this is the line y equals x. So really, in doing the absolute value here, I'm really looking at the integral from 1 to 3 of x dx. Okay? And I can solve that out. Do I need to go any further with that, or?
So is it possible to anti-differentiate like an absolute value?
The way I work the problems is I consider where I am,
Yeah.
and
Is it possible not to do it that way? Don't show me, just yes or no.
if it is, I don't remember.
Okay. JP's not here.
Oh, can I say
Go
this?
ahead.
You must have learned it in college. That was his part.
All right.
Like, I had like a thought, like, wouldn't the absolute value of x would just be like the square root of x squared? That just like works like that.
Square root of x squared. If you plugged in -2 and squared -2, you get 4 square root. Yeah, you could work that one like that. Good deal. That's just not the way I've worked it, but that works.
Yeah, I was just thinking about how to do it.
Why is that? Why?
Because it's basically like, the absolute value of x would be y equals x, but then the negative values would then be positive value. Like, it would, so.
If you plugged in -3,
When you squared it, then that would make all the values positive, and then when you put the square root, it would like, bring it back to
you would just have to do it in that order. Give me a second. I want to try something with that a little later. Okay? That's ridiculous, but I never considered that. Yes.
What if your interval is like -1 to 1?
All right, we'll look at that in just a second. You're getting a little ahead of me. All right. Now, we would solve that out. Did anybody solve it out? It's 4? Okay. I wasn't going to solve it out, but it becomes 9 halves minus 1 half, which is 8 halves, which is 4. All right, now, let's consider going from -1 to -3 of the absolute value of x. Now, this is a little bit more involved. All right. When we're talking about from -1 to -3, what part of the graph are we referring to here? The what? The left side, right? Okay. So here is -3. Here is -1. And we're right here. Now, is there anything that you notice that's a little bit different? Yeah, I've got to switch my limits of integration around, don't I? So I get the negative of -3 to -1. Your limits don't change to positive. The negative allows you to switch them around. Okay? I switch these around because, yes, the bottom term is bigger than the top term. All right. Now, what is the equation of that line for this particular part of the equation? Huh? Y equals -x. Okay. Well, right here, if I pull that negative out front, then what happens? The negative goes away, right? So I'm dealing with the integral from -3 to -1 of x dx. Are we okay with that? All right, now, what is the antiderivative of x? It's x squared over 2, right? From -3 to -1. So filling those values in, I get -1/2 minus... Yeah, thank you. It's 1/2 minus 9/2, right? Am I good there?
Yeah.
Okay. And I get -8 over 2, which would be -4. I got a question for you. This graph right here is above the x-axis. And I said areas above the x-axis have a positive area, right? I've got a negative area right there. Why? I couldn't hear you.
Is it because you take the absolute value, doesn't matter?
No, not quite.
Does anything have a negative?
It graphs below the. All right, they would have a negative. All right, if it's below the x-axis, you would have a positive area, but the antiderivative would show that as being negative. So when you see negative dealing with area, it should trigger in your mind one of two things. And one of those things is that it's below the x-axis. But there's another thing it could trigger off. And I'm seeing if y'all can figure that one out. Be more specific. You're saying a reflection.
Is it because you flipped
Very good.
The opposite direction.
It's because remember how this problem started off. This problem started off with me going from a larger value to a smaller value. So a negative antiderivative, as far as graphs are concerned, can mean one of two things. One of the things it could mean is that your graph is entirely, or the majority of your graph is below the x-axis. But the other thing it could tip off is that you're moving from right to left. You're moving, and I should be more specific, you're moving from right to left with the graph being above the x-axis. Yeah.